Hey folks, I'm Chuck Black. We're doing 52 weeks of Python in 10-minute sessions. Today's topic is Nmap. We are going to show how we use Nmap to scan for open ports on devices. This is where we get this information in Quokka. It's where we get the extended port scan information. And in this code here, we will be looking at different ways that you can exercise Nmap functionality. So let's get started. Okay, let's talk about Nmap. So similar to Scapy, Nmap has web pages with tons of detailed information about all the capabilities that are available. They have a reference guide. They have all kinds of interesting stuff that you can look at to get all of the details about all of the things that it can do. We will be scraping the surface of what is capable of being done with Nmap. In addition, Quokka and Quokka Prime make use of functionality for Nmap. In particular, we use Nmap in order to discover open ports for devices, and this extended port scan that we can do for various devices. We also make use of the Nmap functionality in the worker node. So information such as this comes from Nmap. So let's look at the code and how we exercise this Nmap code to do what we want to do. So we're going to import from Nmap our port scanner. I also will import the port scanner async at the end. You'll see that we're going to create an Nmap object from the port scanner class. And once we have that, we are going to perform scans. Now we can do scans on a single IP address, as you see here. We can also, as you see later on, do scans on a subnet range. So that is one of the possibilities. In this code right here, I'm going to get as input an IP address to scan, and then I'm going to do a scan for that. I'm going to specify the ports that I want to be scanned, and then I pass in these arguments. I do not have time in our little 10 minutes to get where we're getting together to describe all of this stuff to you. There are many different parameters that we can pass in. They specify how we are going to exercise this scanning functionality. This is one way that I do it. In my port scan thread, you can see I have other arguments that I pass in host port scan, which is from just doing what you see in this screen here, not this one right here, but in the screen that has this information about the TCP ports that are open. That is, I use a different set of parameters altogether, arguments altogether. In fact, I don't even specify them. I just use the default, and that gives me what we just saw. So there are different parameters that can be passed. In our example, I'm doing some. You can experiment with different ones if you like. So all we need to do is do a scan on that IP address, and that's what this code here does. Now, in addition to printing out the output that came as a result of doing a scan, the output that you have just looked at here, nicely formatted with pretty print, we can also go into our nm object and ask it to give us all the TCP ports that are open, UDP, IP, etc. So those are useful functions to exercise as well. Now you'll notice that I skipped over this code that I've highlighted. That's because this is a more advanced topic and we don't have time to go into it. If you are interested, you can listen to the long form version of this class, and you can also look at the addendum that I created for it. So let me show you how you run this and also what the output is going to look like. We've seen part of it, but one thing you will have noticed is that I'm running this in a terminal. That's because we require root privileges, so we have to run as super user when we run this, similar to what we've done with Scapy. Now the functionality you will probably understand and be familiar with here. We're in a while loop. We're asking for input. We're asking for an IP address. That's what this is right here, asking for an IP address. In this situation, for this port scan, I typed in this IP address. It began the scan, and it took quite a while to come back, like 15 seconds or so. Some will take many minutes to complete the total scan. It gives us a bunch of this information. That's the request that it made. These are the scan results. It includes things like the IP address, the MAC address, the host name for the device. It will try to match the operating system based on information that it has queried. You can see accuracy 98%, D-Link, etc. As it turns out, this happens to be a doorbell which is connected via Wi-Fi to my house, so it has a lot of guesses there. It's telling me a little bit of information about what it did, and then it tells me the vendor for the IP address, which happens to be Texas Instruments. Not sure how critical that is. And the ports didn't really have any open ports, so as you noticed in my listing of this stuff, sometimes there's open ports and sometimes there aren't. So that is that information. Now the next thing is what we're going to look at. We're not going to look at a single device, but we're going to look at the code to try to do things like discovery, which will use a subnet rather than a single IP address. Now this next code is doing the same thing. This piece of code right here is going through and scanning all hosts using ICMP. That takes a while. We'll look at the output after it's been done. And then this other one is doing exactly the same thing, but we are using an async port scanner. That means that for every device that we learn about, we're going to call the callback. Well, we're not, but Nmap is going to call our callback and we're going to print it out. So this allows us to display devices as they are discovered. This one right here does the entire scan, and then we can iterate through all of the hosts that have been discovered and print them out at the very end. So basically, let's look at the scan here. This is just using my same NM object because this is the normal synchronous one, not asynchronous. We pass in, instead of a single IP address, we pass in a subnet. And this argument right here is the argument that will magically tell Nmap to do an ICMP echo discovery. So it will go off and do that for every device in this subnet. And then when it's done, it keeps the information in this NM object. And that means we can call all hosts. And then we're basically doing a for loop and going through and printing all of them out. Let's just look at the output for that really quick. This is going to be the output, scanning all hosts using ICMP. We're going to be printing all of this information out, which is basically the IP addresses. You'll notice these IP addresses look similar to what you've seen in the Quokka information that I've shown you for my network. So it's doing a similar thing to what the SCAPI ARP ping does, although it does it in an entirely different way, and it gets a certain number of different results. Here is the version which is doing async. It's using a callback, and if we look at this code, basically this scan line is exactly the same up to that point, but the difference is I specify a callback and say discovered host, and then I need to sit around in this loop, and I'm looping while my NM async object that I created up here that I'm utilizing for the scan, while it's still busy scanning, I'm going to continue to wait. So I just sit in this loop until it's done. And every time I discover a new device, this gets called, and basically I'm going to end up printing out this information. And if we look at the output for this, that's what this looks like. I'm printing out a little bit more information. Here, this gives you a better look at it. This is my printing out the callback information that I got. And you did see that I made sure that there was only one total host because I want to have a simple print statement and not print everything out. But you can see the elapsed time for all of these different devices. And of course, here are the IP addresses, which should be similar to what you see up here, 11, 122, 14, etc. That, my friends, is Nmap. At least it's the pieces of Nmap that I use. And as I mentioned, I use Nmap in my worker for doing port scans. That's the extended port scan, and I do it when I do my host monitoring. I also do a port scan, and that is what contributes to this information that you see over here on the right. So Nmap, very useful for scanning devices on your network, finding vulnerabilities, etc. Okay, let's really quickly review what we talked about. We're using Nmap, and we do a scan with Nmap. We specify an IP address or a range of IP addresses. We specify the ports. There are many arguments that we can learn and use. We talked about how we use Nmap in order to get this port information and to do extended scans. Down here we looked at the way that we can do discovery of hosts, in one case using nmscan and waiting for them all to complete, in another case an async scanner where our function gets called every time a new device is discovered. Hopefully that makes sense. If not, let me know, and as always, thanks for listening.